All right, so this is likely going to be the last Regents that you all do before the January 2024 Algebra 2 Regents. This is after we've done the January 2023, the June 2023, and now we're doing the August 2023, okay? All right, so if you were with me the last time, like I said, I've been doing a couple of questions here and there that I think that everyone can get. So least bias, we did say this in the last test. Uh, to minimize bias, you need to maximize randomness. So to have less bias, you need to make it more random is the only thing you need to know for this question. And so whether you get this right or not is irrelevant because we didn't really cover this. However, this is in Algebra 1, kind of just like common sense language problem, okay? So you want to survey every fifth student at the school who's entering the building, every other option, right? Entering the gym. What about people who don't go to the gym, right? That's out. In the junior class, what about every other class? Okay. Entering the library, what about people who don't go visit the library, right? But if we say entering the building, then we can get as big a population that is more random. Okay. All right. Question number 2. We did something like this. This was called the remainder theorem. Remainder theorem. And this is on delta math, but how you start this question is you do x plus 3 is equal to 0, minus 3 cancels out, so you get x is equal to negative 3. Then you take your calculator, you store negative. So how you do that is you hit negative 3, you press the store button, which is above the on button. You need to know this button really well, and you store it in for x, hit enter, and then you plug in the original, the one that's on the top. So 2x to the third plus 3x squared, so on and so forth. And through the magic of video, right, I was able to plug it in, hit enter, and I got negative 10. So what does that mean? That means that the remainder is equal to negative 10, okay? So this one doesn't have a remainder, so that's out. This one also doesn't have a remainder, so that one's out. So this one has a remainder of 74. That one's also out. So the only one that has a remainder, here's the remainder, here's the negative sign. So negative 10 is going to be our answer. The other way to do this question is by using the store button. Pick any number besides 0, 1, or 2. Do not pick 0, 1, or 2. I usually do 2.1, store that in for x. Plug this whole thing into the calculator using alpha y equals for the fraction bar. Plug each of the answer choices in, and you'll also see that 2 works. Okay, so there's 2 ways to do that question. This question right here, given, I did say this in the last video. So given basically is a probability question. And if you understand what I'm about to say right now, you'll get one more question right. But given, the formula for given is there are 2 factors, right? There's pizza and football. So you look at where pizza and football meet, which is 20. So that's going to be 20. That's the number that goes on top. And then what goes on the bottom is whatever comes second. So here it says the fan prefers football. So how many total football players are there, right? If I were to take these numbers and add them up, I'm going to get 40. So 40, sorry, 40. So 40 goes on the bottom. 20 divided by 40 is the same thing as 1/2. Therefore, this is 1/2. Or just guess if you are like, we didn't do this, I don't need to know it. That's up to you. All right. Inverse was our last question that we did do our last lesson. Inverse means you take, this is y equals 12x minus 4. Take x and y, switch it. So you get x equals 12y minus 4. Look for the answer choices that are there. It's not there. So we want to get the y by itself. Add 4 to both sides. Everyone should get this question right. So we have x plus 4 is equal to 12y. And then you want to get the y by itself by dividing both sides by 12. This cancels out, so you get x plus 4 divided by 12 is equal to y, and answer choice 3 says exactly that. Okay. Again, everyone should get that question correct. Number 5. This one also is something that everyone should get correct. This is something that is graphable, right? So we have x plus y equals 4. Get the y by itself minus x, so you get y equals 4 minus x. And so graph that. So you can go to your calculator and go to y equals, go to the table and graph it. Or you can say this is the you can remember that this is our y-intercept. So I have y equals negative x plus 4. So this is our y-intercept. So that's 4. And then you can say that the slope is negative 1, which means that I go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. So I get a line that looks like this. I'm going to draw this to the best of my ability right now. Okay. And so now it says one solution to the system is, and so you can see very obviously that 0, 4, which is this point right here, is one of the solutions. Automatically, a lot of people would say this. That's incorrect, right? 4, 0 is 1, 2, 3, 4. 4, 0 is that point right there. That is not a solution. The other solution is right here, which is 3, 1. So this answer choice is answer choice 4. And again, you're just looking to see where they meet, right? Where does the two graphs meet? So 0, 4 is 1, and 3, comma 1 is the other solution. It's just asking you for one solution. All right. Question number 6. Everyone should also get this question. You can go to y1, y2, and see where they meet, and you could match. So I am going to spend some time going over how to do this a couple of different ways. So for this one right here, right, if you were to go ahead and hit graph, you would see that only one of them would show. And the reason why is because this one, the Y2, you have to change your window. Hit window, hit window, hit window. Come on. Come on, little calculator. You could do this. Okay. And then we want to go to our Y max, right? Because this is our Y and this is our X. So we want to look and see where they meet. So our Y max here is at 56. So we want to go to our Y max and let's go 60. And then hit graph and you should be able to see the actual function. So that's the first one, the 2 parentheses 3 to the x plus 4. And then 56 is going to be a straight line. There we go. And we're looking to see where they intersect. So to do that, you hit second trace. Option number 5 is intersection. So you're going to move your calculator till you get to the point of intersection, which I can see is going to be a negative number. Enter, enter, enter. And it gives me negative 0.966. So x equals negative 0.966, and you're looking to see which one matches that. And here's the graph. So it's not exactly -1, so I can cross that out. So what I'm going to do is I'm going to plug in each of my other choices, right? So if I go to my calculator, option number 1 says log base. So I hit math button, go down to log base. And so all I'm doing is I'm checking to see if it's this right here. So I'm going to do log base 3, go over to the right, put 28, go over to the right again, and -4. And this is my answer, right? That matches with what I had before, which is negative 0.966. So that is option number 1. If I plug the other ones in, just so you know the difference, right? Log without the base at it is above the store button is ln, and above that is log. So if I have log 25, close those parentheses, -4, this is not going to give me the same answer, right? So 3 and 4 also don't work. So only option is option number 1. I'm going to show you how to do this the longer way. If you're like, why, stop it, just deal with it for right now. This is for anybody who's like, show me why that works. So this is 2's cancel out. So I have 3 to the x plus 4 is equal to 56 divided by 2. So if I go to my calculator, 56 divided by 2 is equal to 28. So I have 28 here. And then I'm going to rewrite this with a log. So my base is right here at the bottom. So I put 3 at the bottom. The answer to a log is my exponent. So I'm going to put the x plus 4 over here. And then I'm going to put 28 right here. This is already looking like my answer choice number 1. To get the x minus by itself, I'm going to subtract 4. So -4. And so this cancels out. And so if you take a look at this right here, isn't that exactly answer choice number 1? Okay. All right. Number 7, this one is one that you can completely guess on. It's completely fine. Random that I probably wanted both, blah, blah, blah. So this is, for those of you that are like, how do you do this? Don't worry about it. But yeah, option number 4 is the correct answer for this. Which quadratic functions have imaginary roots? For this next one right here, so I want to refresh your memory about what imaginary roots are. This has real roots, right? It's where it crosses the x-axis. Imaginary roots are where it does not cross the x-axis, like for example, like that, okay? So in saying that, automatically I can see that j of x is going to have imaginary roots. It can look like that, or it can look like this. It does not cross the x-axis. So anything that has j of x in it is going to be part of our answer. So then how do you find out the others, right? So they tell you, they give you a couple of clues. They say the function f of x has a discriminant value of 8, which means that, you know how we have this negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is specifically, let me change colors, is specifically what's under the radical. So they're telling us that this number is equal to 8. So if I do the square root of 8, that's going to have real roots, which means that it's going to cross my x-axis. But if I look at g of x has a discriminant value of negative 16. So if I have b squared minus 4ac is equal to negative 16, that means that my roots are going to be, right, when I do the square root of negative 16, that's going to give me an imaginary number, which means that my roots are going to be not touching the x-axis. So option number 2 is going to be my answer. And again, how do you know? The square root of a negative number is going to give me an imaginary. This is going to give me 4i. Square root of 16 is 4. Square root of a negative sign is going to give me I. All right, question number 9. We did have something like this. It tells you it's a half-life. So half is what's going to be in the parentheses. So automatically option number 2 is out. And then our initial amount is a sub 0. So we have this right here. We did something like this along with compounding. So I don't know if you remember our lesson that we did on continuous growth, but this is our formula. So a0 is our initial value, t is time, and h is our half-life. Okay, so all of that to say, so it's always going to be a half in our parentheses. And then if we take a look at our problem, I just wanted to see if I could Google it for you. Oh, where is it? Oh, here. Okay. So if you take a look at our problem, we have a sub 0 is our initial. We're going to plug in the 1/2 because it is a half-life. And then our t, which is our time, is going to get divided by what is our half-life, which is our h is 25. So our answer that matches that is choice number 1. Okay. Which function has the greatest y-intercept? So y-intercept is where the graph crosses the y-axis, whether it looks like that or like that. So you're looking to see the greatest one, the one that is higher up. So this is easily graphable. You can graph each of these and see which one has the greatest y-intercept. That specifically happens to be option number 4. If you were to take a look at the graph of that. I trust that you can all plug this into the calculator because we talked about how to graph different functions. I'll do the first one for you, 4 sine 2x. So just for this one right here, let's clear. So y equals, right, let's clear what's there. And then we're typing in the function, which is 4 sine 2x. So you hit 4, hit sine 2x, close parentheses, and then we're looking for our y-intercept, which in this case is going to be 0. So our y-intercept here is equal to 0. Our y-intercept here is equal to 7. So far right now, the bigger one is 7. For option number 3, our y-intercept is going to equal 8. And for the last one, our y-intercept is going to equal 12. So this was the greatest y-intercept. And again, graph each of these and look across from 0. Across from our 0, that number is going to be our y-intercept. Question number 11 is honestly, you're just looking for the model can be best represented by. So you have a function here, and you're looking to see which one is going to be the same thing as that. Okay, so the easiest way to do this is the initial amount, as you can see, is the same for all of them, 12,150. But then we're going from T years to D decades, which means that you have to take the amount that it's growing or decreasing at, right? In this case, it's less, this number is less than 1, so it's going to be decreasing. So we're going to take this 0.962, and then how many years are there in a decade? That is 10. So 0.962, if I take my calculator here, and I go to my regular calculator here and I do 0.962 and I raise it to the 10th power, this is going to give me our new parentheses, right, with the number that goes in parentheses. So this is about 0.678, it might even be 679, okay, 0.679. So that's going to be our new number that goes in parentheses. So the 12,150 is going to stay the same. Now I have 0.679, and this is going to be raised to D decades, and that is what answer choice number 2 says. Okay. Question number 12. So this is a question that you could have done in geometry. It's in quadrant 2, so we know we have something that looks like this. Here's our right triangle. They told us that sine, right, here's our angle. Sine is equal to, remember SOHCAHTOA? So sine of the angle is equal to opposite over hypotenuse, and they're telling us that this number is 2 over 5. So the opposite is going to be 2. Our hypotenuse is going to be 5. And they're asking us the value of tangent. So tangent, TOA, is equal to opposite over adjacent. So the side that is opposite, again, here's our OPP, here's our height, and here's our adjacent. So the top number is going to be 2. That's our opposite. And then for our adjacent, we need to find the adjacent number. So remember, a squared, refreshing your memory, a squared plus b squared is equal to c squared is our Pythagorean theorem. So we need to find out what is our adjacent equal to. So we're going to put 2 squared plus our adjacent, which we don't know. So I'm going to call that a squared is equal to our hypotenuse, which is 5 squared. 2 squared is 4 plus a squared is equal to 25. Subtract 4 from both sides, I get a squared is equal to 21, and a is equal to the square root. So I do square root here, so a equals the square root of 21. So that's going to be our number that's in the bottom. So we have square root of 21. We do need to remember that this is a negative number because we're going left here. So this is going to be negative radical 21, which is what answer choice, this is a negative sign, which is what answer choice 3 says. If you get this right, great. If you don't, it's okay. All right, next question. This is also a calculator question. So if you were with me the last couple of tests, right, for the June and for the January one, so for this one, whenever you see something that says normally distributed, there's a mean, there's a standard deviation, and we're looking to find, okay, a range. So it falls below 21. So if I look at a number line, here's 21. So below that is going to be, our range is going to be between 0 is our lower and our 21 is our upper. Our mean is the same thing as our U, which is 23, and our standard deviation is going to be 1.2. Okay, so where do I put these numbers into the calculator? You hit second vars, option number 2, and I did not teach you this, but this is an easy one for you to do. Our lower is going to be 0, our upper is going to be 21, our standard deviation is 23. I'm sorry, our mean is 23 and our standard deviation is 1.2. And then you literally just hit enter, 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 and you get 0.0477 as a percent. It's telling you percent you're going to move this decimal 2 places to the right or multiply by 100. So that's going to be 4.78%, which is answer choice number 2. All right, next question. So this might require you to like take a look at this. And so we have this exponential equation, right? It's growing exponentially. And so we want to find out what is the A is our initial amount. So our A here, if you read the question, 105 students entering the building. So our A is 105. And they're also telling us that it is decreasing at an exponentially rate. So we have y equals a b to the x power. So our a is 105. Our b, since it's decreasing, we know that this number has to be between 0 and 1. So it's like less than x less than 1. It can't be 0 or 1. So what do we know? We know that both these numbers right here, this is going to be to the x power. We know that both of these numbers are a and are b. This is positive, right? So anything that says a is negative is wrong. And this number right here is going to be between 0 and 1, which is also a positive number. So we can say that both a and b are positive, okay? This number, the only thing we know about the number that's in the box is it has to be between 0 and 1, okay? Which is a positive number. All right, solution set. You could store each of these numbers, hit enter, see which one works. You could plug it into the, like, so this is what I mean by that, right? You could hit 6, store in for x, hit enter. You could put square root of 3, parentheses, x plus 6, close those parentheses, hit enter, and that gives you 6. So 6 does work, and you could do the same thing for the -3. Let's see if option number 1 works. So -3, we could store that in for x, hit enter, and we can go up and grab this just because I'm being lazy. And if I get -3, that does work. I don't get -3, I get 3. So that means that anything that has -3 is wrong. And the only one that works is 6. Okay, number 2 says -6. That's out. Or you could do y1, y2, go to the table and see where your y1s and y2s are the same, where this and this are the same. Okay, the only one that's going to work for is number is 6. All right, the next question right here. This looks crazy and difficult, but it's not. It's just they even tell you what each of the variables stand for. So our principal, we're borrowing 45,000, so that is our 45,000 right here. They're telling us that the rate is 6.75%, so you're going to put parentheses here, see, our R. So you're going to do 6.75 over 12, because it's always over 12, and then you have 1 plus our rate again is 6.75%. You should get this right. This is just matching, plugging stuff in. Again, it looks crazy. They want it to look crazy. So now we're looking for our time here. Our N is our number of payments. So if you take a look at, there's a monthly loan for 5 years. So N is going to equal 12 times 5, which is equal to 60. So we're going to put a 60 over here, and on the denominator is going to be parentheses 1 plus. Our R again is 6.75 over 12, and this is again raised to the 60th power. This is minus 1. So put this whole thing into the calculator, hit enter, and you're going to get 885.76. Okay. If you don't get that, then let me know, so I can show you what you did wrong on the calculator, but that's how you do that one. Number 17. So discounted every 10%, by 10% every Monday until they are sold. In how many weeks will an item costing $50 be first be sold for under half price? Okay. So we're starting, so this is our A equals P. This is going to be 1 minus, specifically because it's discounted, so 1 minus our rate to the T power. Okay, so we're starting at $50. 1 minus, it's 10% off, so 1 minus 10%. So 0.10 is going to be the same thing as 0.90. So that's what's going to go here. We're going to raise it to the t, and we want to know where is it going to be under half price. So half of 20, I'm sorry, half of 50 is 25. So we want to find out what this is equal to. So you could put this into the calculator, y1, y2, and see where they meet, or let's just do this the longer way, divide by 50. So this cancels out, so I have 0.9 to the t is equal to a half. I can rewrite this with a log, so log with the base of 0.9 of a half is equal to t, and so I take my calculator. Let's clear what's there. So I'm going to hit math, go down to log base, put in my 0.9, put my a half, 1 divided by 2, and then hit enter, and I get 6.57, which rounds to about 6.57 is about 7, right? So t is about 6, not 0.6, 6.57, which is about 7. I'm going to round it up, okay? All right. In which interval is f of x always positive? So f of x is my y. So it's basically asking you where is y positive. So y is positive here. Here's my y from here to here. So negative, let's see what this is. This is negative 2. This is negative 6. This is negative 10. So I have from negative 10 to 0. Okay, so from negative 10 to 0, my y's are positive. See that? This is where my y's are positive. So negative 10 to 0. It's also 0 here, right? From here up. So this is from 9 to infinity. But I don't have anything that says that. So my answer that's there is option number 4. Question number 19. We're doing good. So all I have to do for the next question for number 19 is graph them. So I plug my y1, right, is my f of x. So I plug this under y1, I plug this under y2, and I'm going to see where they meet. So I don't care where they meet, actually. I just want to see how many times, okay? I'm not looking for where, I'm not looking for numbers. So I'm just going to plug them in, and I'm going to hit graph. So I'm looking to see how many times does my blue line and my red line meet. And so they only meet, if I were to take a look at this, right, they meet twice. I don't know why I did it like that, but let's just see if it'll do it again. Are you gonna work? Okay, whatever. So anyway, they only meet twice on the right hand side. So I go over here and I circle or put a box around 2. There are 2 real solutions. Which expression is a factor? So I want to refresh your memory. Factors mean that when I store my number in, it's going to give me 0. So if I were to take this, the opposite of positive 2 is negative 2. So I'm going to take my calculator right here. I'm going to store negative 2 in for my x, hit enter, and then I'm going to plug in my function. And once I plug in my function, if my answer is 0, that means that that number is a factor, right? So negative 2 uh, gave me a 0, so that means that my answer is x plus 2. So basically all I do is I flip the sign. If I'm going to just show you the next one. So if I have x minus 2, set that equal to 0, I add 2 to both sides, I get x equals 2. Watch what happens when I store 2 in. Again, because I'm lazy a little, I'm going to go over here, take out my negative sign, hit enter, and then I'm going to go up and grab this whole thing, hit enter. Do I get a 0? No, I don't. So this does not work. If I were to set this equal to 0 and I switch the sign, I get x equals negative 5. If I store negative 5 in, you'll also see that it's not going to work. It's not going to give me a 0. I'm going to prove it to you. So if I have negative, and let me insert my 5, hit enter, go up and grab, that is also not going to give me 0. Okay, so 3 and 4 don't work. Only answer is number 1. Next one is equivalent to, right? I can use the store button. So store a number in, I usually use 2.1. So I'm going to take my 2.1, store it in for X. I forgot to press the store button, which some of you might do. And then I'm going to plug in my original, which is X second plus 6, right? So the magic number that I need to look for is 1.2378, 1.2378. So automatically option number 1 does not work. And if I plug in each of the other ones, the one that gives it to me is going to be option number 4. Let me just show you that. Alpha y equals option number 1, 2 over x squared plus 4. And if I hit enter, I'm going to get the same thing, right? And again, I'm looking for what gives me that same value, because it says is equivalent to. Okay. Question number 22. So this one, they even give you the formula, right? R of x minus c of x. So R of x, if I take a look at that, I am given my my thing that I just have to plug in. So the company profits could be modeled by. And they tell us that R of x is equal to x times s of x. So I'm going to take s of x and I'm going to multiply it by x. So that's going to give me 95.4x minus 6x times x is 6x squared. So I'm going to take these two things and subtract it. So when I do subtraction, I can do this. Think of it as, let me change colors. The negative sign gets distributed between all of these. So this becomes negative 0.18x to the third minus 0.02x squared minus 4x minus 180. And so I'm going to combine some like terms here. So I have, when I do that, I'm going to get option number 3 here. So automatically I see that I'm looking for something that has a minus 180, and option number 3 is the only one that does. Is a way to kind of be like, oh, I don't need to do the whole thing. Okay, even functions. So we did do this. Even functions are where you have something that if you split it down the y-axis, it is reflexive or symmetrical with respect to the y-axis, which means that the left side looks like the right. So if you have something that looks like this, that is also even. If you have something that looks like this, right, that is also even. So the only one that does work with that one is going to be x squared plus 1. So graph it, and you're going to see that. Let me go back real quick. You're going to see that x squared plus 1 looks something like this, which is on the same thing as the left and the right. Okay, nothing else looks like that. P of x is written as a product of linear factors, da 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 da, which factor would appear twice. Okay, so this one I do want you to get. So this one is a factor, right? So 1, 2, 3. This is 3, which means that if I have my function, I'm going to switch the sign. So the opposite of positive 3 is negative 3, so I have to flip it. This one right here is also a factor, right? To 0. So this is x minus 2, right? Which if the minus 2, if I switch it, that's going to be x plus 2. And since this hits it twice, see this? So look what's happening here, right? This one goes through. So it's like reverse. It's like in Uno, that's like a reverse sign. Here, if I have a reverse, right? It's like it comes back to me. So this right here is going to be raised to the second power. So it's asking you which factor would appear twice. The one that appeared twice is the x plus 2. All right. If you didn't know that, it's one of the ones that you can get wrong. All right, moving on. This one, you should never get this one wrong. Whenever there's 4 terms, you split it down the middle, factor out the left, factor out the right. So here, what goes into both of these is x squared. So I'm left with a 2x minus 3 here. Over here, I'm going to have a 2x minus 3 in my bubble. So what comes out? A minus 9. Whenever it says completely, that means that you're going to have to factor twice probably. So let me tell you what I mean by that. So here, right, you see the 2x minus 3. We're going to take that and we're going to write it down once. and we're going to write down whatever is left. If the 2x minus 3 goes away, I'm left with an x squared. If the 2x minus 3 goes away, because I wrote it already, I have a minus 9 left over, right? So that's going to go here. This is going to go here. Okay. Now, this is what I meant when I said, when it says factor completely. So the 2x minus 3 is done. That is factored as much as possible. However, the x squared minus 9 can be double bubbled into x plus 3 and x minus 3. These 2 points you should 100% get. Algebraically determine the value if you did this with a straight calculator, right? And what I mean by that is you go to y equals and you graph and you look to see where they meet. If you were to do this straight calculator and go to your table or change your values, you can see that across from 1 there's a 4 and a 4, which means that 1 works, and if I were to go over to -1, that also does work. So your two answers here are x equals +1 and -1. You could write it like this: x equals +, -1. If you just wrote this answer, you would get 1 out of 2, which again, 1 out of 2 is better than 0 out of 2, but let me show you how to do this correctly. This is from Algebra 1, right? Y equals both of these, right? This and this, so you set it equal to each other. X squared plus 8x minus 5 equals 8x minus 4. This is how you get the full 2 points by solving, okay? So we're going to zero it out by subtracting and moving things over. It's easier to keep this x squared right here positive. So we have x squared, the 8x and the negative 8x cancel out. -5 plus 4 is -1 equals 0. There are two ways to do this. You could double bubble x plus 1, x minus 1, or you can go add 1 to both sides, and you get x squared equals 1, the square root, x equals +(-1). So the square root of 1 is +1, but it's also -1, and that's how you can show all your work and get your full 2 points for this. Solve the equation. So for this one right here, the easiest way to solve is by looking in your formula booklet and using this (b), right? This is a story about a negative boy. He had a choice to go to a party, but the boy was a square, so he missed out on 4 awesome chicks, and the party was all over at 2 a.m. Okay, so how you do this question and get it right every single time is your a is 3, your b is equal to the number that's in front of the x, which is a 5, and your c is equal to the number that's chilling by itself, which is an 8. So the formula says whatever your b is, you do the opposite of it. So the opposite of 5 is -5 plus or minus b squared. So we're going to put 5 squared minus 4 times a, which is 3, times c, which is 8, all over 2 times your a, which is 3. Okay. Now you take your handy dandy calculator. You with me? Are you with me? And you just literally plug in what's under the radical. So 5 squared minus 4 times 3 times 8. And when you hit enter in the calculator, you get -71. So -5 plus or minus the square root of -71 all over 2 times 3, which is 6. And it says write your answer in a plus bi form, which means basically you're just going to split it. Okay, this is what I mean. -5 over 6 is one fraction. This right here is another fraction. So how should you write your answer? -5 over 6 plus or minus the square root of, right? Anytime you have a negative under a radical, and I comes out. And then, so this is the square root of 71 uh, times I. So this is going to be radical 71 over 6i. Okay, so this whole thing is your answer for this question. Doot, 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 doot. And you're done. Okay, that's how you get the full 2 points. This next one, like I said, I'm going to show it to you. If you were with me on the last test, the June 2023, you should be okay with this. If not, you're going to get it wrong. Oh well. So it has a midline of -2. So -2 is going to be our midline. That's where it's going to cut the graph in half. Okay. The amplitude is 3. So the height of my graph is 3, equals 3. And then we are going to do a period. So the period is pi over 2. So period is equal to pi over 2. The formula for period again is 2 pi over whatever your b is. Okay, so let's figure out what this is going to be. So we're going to go, here's a cosine function. So what we should know about cosine is it starts at our high, it's going to go down and come back up. So we're going to sketch one cycle of this. Okay, so if it cuts the graph in -2, right here at -2. This is where it cuts the graph in half. If I have a height of 3, I'm going to go 3 up. So 1, 2, 3, right here at 1, that's where my graph is going to start. Okay, at 1, it's going to come down to 3 below this, which is -5. It's going to come somewhere around here, and it's going to go back up to where this 1 is right here. And for a full cycle right here, this is going to be pi over 2, because a period is how long it takes to make a full cycle. Okay. Again, question 28. If you didn't understand anything of what I just said, skip it. Okay. For question 29, you should all get this right. So this is 5xi to the third minus 4i squared means that you're going to multiply it by itself. So 5xi to the third minus 4i. So when you do this, you could use box method. If you like box method, great. If not, then do it with first, outer, inner, last. So 5xi to the third minus 4i, 5xi to the third minus 4i. 5 times 5 is 25. X times x is x squared. I to the third times I to the third is going to give me I to the, add them, so that's going to give me I to the sixth. Okay. All right, so that's my first one right there. I keep going. -4 times 5 gives me -20. The x comes down, and I to the third times I is I to the fourth. I do the same thing over here. This is also going to give me the same thing, -26x, I'm sorry, -20xi to the fourth. And then the last one is -4 times -4 is 16. I times I is I squared. It says, and then they want us to simplify this. So 25x squared, I to the sixth, I'm going to go to my calculator right here and just type in I, which is second dot, to the sixth power, hit enter. So I get -1, so this whole thing is going to be multiplied by -1. So when I solve that, positive times a negative is a -25x squared. Okay, that's my first one. These babies right here are going to get added together, so that's going to be -40x I to the fourth. So if I go to my calculator here and type in I to the fourth, again, I'm lazy, so I just go up and grab it, and I change this to I to the fourth. I'm going to get 1. Beautiful. So this is just -40x, because I to the fourth is equal to 1. Okay? A 1 times anything is itself. All right. And then the last one, I have positive 16I squared. So I'm going to take my calculator, right? I squared, hit enter, and that's going to give me -1. So this is going to be 16 times -1, which is -16. So this whole thing right here is going to be my final answer, because it says put it in standard form. Okay. All right. This next question, you should not get this wrong. They give you a vertex and a focus. So the way I showed you to do this is always with the graph paper. So you're going to go to your graph paper that you have, or you can sketch it. So they're telling us that the vertex is -27. So I just went to -27, I put a dot, and they told us that the focus is -28. So I went to -2, 8, and I put a dot. Okay. Remember, the one thing that you do need to know is the vertex is in between the focus, wherever the focus is. Here's the focus, and the directrix. So the directrix is going to be somewhere right here. Directrix, and here's the vertex. Okay, so we can tell right here. Okay, this distance is 1. Our p is equal to 1. So that means that our directrix is going to be one away on this side. So this right here is going to be our directrix. What is that line? That's right at 6, right? This is 8, this is 7, this is 6, the same distance away. So what's our directrix? Y equals 6. Done. Done, right? So as long as you have that, you go to your question, and you actually don't even need this right here, right? What you do is you literally just sketch. So here's negative 2, 7. So this is our vertex. You go to negative 2, 8, which is our focus, and say that this is 1. So our P is equal to 1. So our directrix is going to be right here at 6. So Y equals 6 is the directrix. It says use this information to explain. So now we have to explain. We have to explain. So we can say P is the distance from the focus to the vertex, focus to the vertex, which is 8 minus 7 equals 1. So our P is 1. And then we could say also that P is also the distance from the vertex to the directrix, vertex to the directrix. So 7 minus 1 is going to equal 6, and so Y equals 6 is our directrix. Right, so all we had to do is explain it. Very simple. Done. Question 31. So rewrite this as a single term. All right, so we have x and then times, and I have a square root here, so I can rewrite x with a fraction as a exponent. So this is the, let me make this a little bit bigger, right? So if there's no number here, there's an imaginary 2. So our 2 is our root. Roots go on the bottom. And our 3 is our exponent. So the exponents go on the top. Okay. And then over here on the bottom, I have x to the, and again, I'm doing the same thing. Our 3 is our root, so that goes on the bottom. And our 5 is our exponent, so that goes on the top. And it says rewrite it in simplest form with a rational exponent. Okay, so there's no exponent here, there's an imaginary 1. So I go, if I'm multiplying these, that means that I add the exponents. So I go to my calculator here, turn it on, let's clear whatever's there. 1 plus 3 halves, so alpha y equals, option number 1, 3 over 2. Hit enter, and I get 5 halves. So this is the same thing as x to the 5 halves divided by, this is x to the 5 thirds here, 5 thirds, right? And so when you're dividing, you subtract the exponents. So 5 halves minus 5 thirds is equal to 5 sixths. So x to the 5 sixths is going to be our exponent. And it says rewrite it with a rational, which means fraction exponent. So here's our fractional exponent, x to the 5 sixths. Okay, that is question 31. Question 32. Average rate of change, unit 1, lesson 1. Everyone should get this right. Okay, so what we're doing is we have over this interval, so here's our x1, x2. So if I were to rewrite it as a coordinate, my 0, comma, and if I were to write, here's my x1, and this is my x2, which is 10.5 is my x2. How do I find my y1 and my y2, right? Plug it into this function right here. So I go to my calculator, go to y equals, let's clear what's there. So I'm going to do 10 parentheses 1.27 to the x. And I'm going to look across from 0, right? So across from 0 is 10. So here's my y1. And across from 10.5 How do I get 10.5 in my calculator, right? Second window, and here I'm going to put 10.5. And then I'm going to go to my graph. So second table, so I have 123.01. So this is going to be 123.01. So there's my y2. And then you have your formula, y2 minus y1 over x2 minus x1. Okay, so y2, 123.01 minus y1 all over x2, 10.5 minus 0. Go straight into the calculator. Literally straight into the calculator, and I get about 10.76. It says round my answer to the nearest hundredth. So this is about 10.76 fruit flies per day, right? Fruit flies per day. It says include appropriate units. So we do need to write fruit flies per day. All right. Whoo! This is sketch. Beautiful. I like sketching. I don't need to be exact. So I'm going to go to my calculator. Let's clear what's there. I have a negative sign, log with a base. So hit math, go down to log base, option number, right? Plug in the 2, parentheses, x plus 3. And this is plus 2. And then all I have to do is hit graph. So I want to sketch it. Okay. So here is what's happening. Okay. So now this one, this is worth 4 points. 4 points. So we want to try to get all our points. Okay. So what we want to do is let's go to our table and let's find some critical values, right? Second window, second window. Let's go to 0, second table. So I want to be as exact as possible. So across from 1 is 0. So this is 1. So 1 comma 0. I'm going to put a point there. Let's see another good one to plot. 5, negative 1. Okay, so 2, 3, 4, 5. And then I'm going to go to negative 1. So 5, negative 1. I'm going to put a dot. Okay, let's see some other dots to put. Notice what I'm doing, right? I'm going to hold numbers. So negative 1, 1. So negative 1, positive 1. I'm going to put a dot. Okay, so now I'm going to go ahead and get this to match my graph. So what's happening here, right? I have something that looks like this. I have this, I have this, and it's going to keep going here, and it's going to keep going here. Okay, so I know the calculator looks like it's cutting off right here at the top on the left-hand side. Okay, but my numbers there on my calculator are like, if you take a look, right, it says error, negative 2, 2, so negative 2, 2 is another point right here, right? And so these numbers are actually going to keep going. But what's happening here is these numbers are getting like, it's not that it's disappearing. In log, it doesn't show you the full graph. So what we do is we put an arrow saying that it's going to keep, we know it's going to keep going, okay? So now it says describe the end behavior as x approaches negative 3, okay? So as our x, let me do this in a different color so you can see it. As our x approaches negative 3, right? So here's negative 2, here's negative 3. So as x approaches negative 3, what's happening to our y's, right? Our y's are going, we notice this, it's going up. So that means that our p of x is going up as high as possible, which means it's going towards infinity, okay? Now let's look at the other side as x approaches infinity. So as we go to approaches infinity means as we go to the right, what's happening to our y? It's going, what do you notice? It's going down, right? This is going down. If I'm being dramatic, it's going down, 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 down. Eventually, eventually, eventually. I'm not going to actually draw that, but that means that our y's are going down as much as possible, right? It's going like this. So this is going towards negative infinity, okay? So that means that p of x is going towards negative infinity as x approaches positive infinity. All right, solve algebraically. If you don't know how to do this, y1, y2, see where they intersect. Okay, graph it and see where they intersect. I'm going to do this algebraically because I want you to get your full 4 points. So how do we do this? We have to get our denominators to be the same. So I'm going to take this right here and I'm going to factor it. So let me leave a little bit of space, make this a little bit bigger. Okay. So how do I factor this right here? X, I'm looking for two numbers that multiply to give us 12 and add to give me -8. Okay. So 6 and 2 works. They have to both be negative because it has to multiply to give me a positive and add to give me a negative. So I have x minus 6 and x minus 2. Okay. So that means over here on this side, you see how I have the x minus 6, right? So x minus 6 is there. X minus 2 is not there. So I have to write x minus 2. Whatever I do to the bottom, I do to the top. All right? We did do this lesson. I want to make sure that you realize that. Okay? Over here, we have x minus 2. What's missing, right? We need to have x minus 6 there as well. So let's put it there. X minus 2 is there. So now these are the same, okay? This whole thing, x squared minus 8x plus 12 factors to be x minus 6 and x minus 2, okay? As soon as you get the denominators to be the same, what do, right? Take out your, we did this during Halloween specifically, right? So the whole denominator now goes away. I didn't do one thing over here, okay? See how I multiplied this by x minus 6? Whatever I do to the bottom, I have to do to the top, okay? All right, so now what do I have left? I have x minus 2 times 1. Then I have plus, I have x times x minus 6 is equal to 4, right? Because I didn't have to multiply this by anything, okay? So don't do what I did, right? Whenever you're multiplying, right? You see this x minus 6, I didn't multiply it on the top, so make sure that you remember to do that, all right? So now, let's see. So 1 times anything is itself, so that's going to be x minus 2 plus x times x is x squared. X times -6 is -6x equals 4. Okay, let's do some combining like terms here. So I get x squared, right? This comes down. My x and my -6x makes it -5x. My -2, right, doesn't match with anything, so I'm going to put -2 equals 4. So I'm going to move my 4 over. I'm going to zero that out. So -4, -4. So I get x squared minus 5x minus 6 is equal to 0. Okay. So now again, I'm going to double bubble this. So two numbers that multiply to give me -6 and add to give me -5. What are they? -6 and +1 should work. Yep, that works. So x minus 6 and x plus 1, set them both equal to 0. Okay. So all that means is I'm going to go like this. X minus 6 equals 0 and x plus 1 equals 0. Add 6 to both sides and I get x equals 6 is one of my answers, I think, and I have to do the same thing here. Minus 1, so x equals -1. Last step. Again, this is worth 4 points. So go back to the original, right? This is what we did originally. This is our original problem. Whatever was originally there. So you're going to go here and you're going to check the two numbers that we have. So we have 6. Look what happens here. 6 minus 6 equals 0. We can never have a 0. Can never have a 0 because 1 divided by 0 is going to give me an error. Can't have that. So what does that mean? Our x equals 6 is not going to work. So x equals 6 is not going to work. So cross it out. Now let's check our -1. And if you didn't know that you could do it like this, right? If you take your calculator and you go here to our y equals and you were to plug it in, it's clear what's there. So if you were to go to your y equals and plug in your original, right? Like let's just say we were checking our work. So we have x equals 6 and -1. If I hit second graph and I go across from 6, you see the words error, right? So that means not all errors are the same. So x equals 6 does not work because it has an error. So that's also what verifies that we have to cancel that out. So x equals 6 does not work. Let's check -1. So if I go second window, I'm being a little bit lazy here. It's all fine, but I'm also showing you some steps. And then I go to my calculator. Across from -1, I see 4 over 21 and 4 over 21, which means that this works. So x equals 1 is my only solution. Don't forget to check your work. Check your work. You have 3 hours on the Regents. You don't need to worry about leaving early. Check your work, okay? That's horrible explanation points. All right. Exclamation points, not explanation. All right. All right, we're almost done. We're at 35. So if you know nothing else, go to your calculator, hit the apps button, polysimult 2, okay? Press any key, boom. Option number 2 is simultaneous equation. There are 3 equations, so you're going to go over to 3, hit enter. There are 3 unknowns, so go over to 3, hit enter. You're going to hit next, which is the graph button. You're going to put the numbers in. Up in front of the x, there's a 2, hit enter. 4, enter. -3, enter. You should be doing this with me. Okay, keep going. 3, enter. I'm taking time to do this on purpose, okay, to make sure that you at least get 1 point for this question. At least 1 point. There's a -1 in front of that last x. There's a 1 in front of that y. There's a -3, enter, and a 0, enter. Okay. Then you hit solve, which is graph, and you get your values. So you have so far right now that x equals -1. Look what I'm doing. I'm getting 1 point. I have my y is equal to 5, and I have my z is equal to 2. So right now, I am guaranteed 1 point. Every point counts, okay? How do you do this algebraically for the full 4 points? So this is how you do it. I'm going to do this as slow or as quick as possible, all right? So the first thing I want to do is I want to get rid of one of our variables, either x, y, or z. So I'm going to start with these two right here. Right now, if I add anything, nothing cancels out, so that's not really helpful. But what I can do is I can take a look at my yeah, I can take a look at this and I can say, hey, can I get rid of the y? So life would be great if this, instead of a -2y, was a -4y. So how do I do that? I multiply this by 2, okay? So my first, the top one right here stays the same, 2x plus 4y minus 3z is equal to 12. But the second equation, I'm going to multiply that by 2. So that's going to give me 6x minus 4y plus 4z is going to equal, right, -9 times 2 is -18. Okay. Now, why did I do that? I did that so I can get rid of that. So 2x plus 6x is 8x. -3z plus 4z is plus 1z. And -18 plus 12 is -6. Okay. All right. So that's the first thing that I did. So now I got rid of the y. Okay. Now I'm going to pick any other 2 equations. So let me just erase this. So if I pick the bottom 2, let's go purple, right? If I pick these 2 right here, to get my y's, I still want to get my y's to cancel out. To get my y's to cancel out, I need that to be a positive 2y, because on the top is a -2y, which means that I have to multiply this whole thing by 2. So 3, right? The 3x, I'm going to rewrite this, 3x minus 2y plus 2z, which is our second function, stays exactly the same. However, this one, the last function, gets multiplied by 2. 2 times -x is -2x. 2 times y is positive 2y. 2 times -3z is -6z. And 2 times 0 is 0. Okay? So what does that allow me to do? Again, bloodbath, right? Look what happens. I have my -2y, positive 2y cancel out. So 3x minus 2x is x. 2z minus 6z is -4z is equal to -9. Okay. Now I'm going to take these two functions and I'm going to work with just those. 8x plus z equals -6 and x minus 4z is equal to -9. So I have to get one of them to cancel out. So let's come up with a plan. Let me do brown, okay? So I can multiply this by 4 to do plus 4z minus 4z. That'll cancel out. That's one plan. Or I can multiply this by -8. It's up to you, whichever one you want to do, okay? Since I like it keeping it simple, I'm going to multiply this one by 4. So 8 times 4 is 32, so I have 32x. 4 times z is 4z is equal to 4 times -6 is -24. And I'm going to leave the bottom one exactly as is. Okay. What does that allow me to do? Again, bloodbath, right? 4z minus 4z cancels out. So I am left with 32x plus 1x is 33x. So I have 33x is equal to -33. Divide both sides by 33 and you get x equals -1. Okay, so that's the first one. Boom. So now I'm going to take this x equals -1. I can plug it right in here. So this becomes -1 because x is -1 minus 4 times z is equal to -9. Sure, let's add 1 here, cancels out, so -4z is equal to -8. Divide both sides by -4, and I get z equals 2. Okay, so now I have my x, I have my z. I can go back and I can check my work, right? X equals -1 I got, and z equals 2. How do I get y? I take it and plug it back into one of my originals, right? So here's my originals. I can plug it into whichever one I want. So I already know, why don't I plug it into the last one? Okay, it's the easiest looking one. So my x is -1, so negative parentheses -1 plus y minus 3 is equal to 2. I'm sorry, not my 3. My z is equal to 2 equals 0. Negative negative is a positive 1 plus y 3 times 2 is 6. Okay. 1 minus 6 is -5. So I have y minus 5 is equal to 0. Add 5 to both sides. I get y equals 5 is my last one. Okay. So on my paper right now, I have work for each of them. It happens to work to give me different colored pencils. Okay, so maybe bring that with you, or use pen, pencil. All right, question number 36. We did not do anything like it, um, but I can just show this to you real quick. Anytime it says 95%, you do mean plus or minus 2 times your standard deviation. So here our mean is 0.01 plus or minus 2 times our standard deviation, which is 0.38. And so you have two cases here, right? You have 0.01 plus 2 times 0.38, and you have 0.01 minus 2 times 0.38. Plug this into a calculator, you get 0.75, and then plug this into a calculator. Well, this one right here would give you 0.77. Let's see. Calculator, come on, quit. Number 6. Okay, so 0.01 plus 2 times 0.38. And again, we did not do this, so don't worry. And then when you plug the other one into the calculator, you're going to get instead of plus, we're going to do a minus sign. This is why I saved these to do it at the end, because it's not hard. So we have this one is -0.75. So what is our interval? It's going to be from -0.75 to 0.77. And again, you did not know this, but I'm going to just show this to you now. Okay, don't worry about the other one. All right, so right now we're leaving that last question on the table. This next one, though, you should definitely get correct. This is question number 37. This is where 3 multiple choice questions, okay? Um, where are we at? All right. So when we have Abby and we have Brett, so they both invested $8,000. Uh, Abby pays 4.2% interest compounded quarterly. Okay. So, and then Brett compounded continuously. So let's remember our formulas. For continuously, it's A PERT. This is compounded continuously. This is our finance lesson. Okay. For compounding any other way, our formula is A equals P, parentheses, 1 plus R over N to the NT power, okay? So all we're doing now is we're plugging in some numbers. So we have Abby, A of T, that's our Abby function. So she starts out with 8,000, okay? It's 1 plus our R, Abby pays 4.2, so we're gonna put 4.2, right? But we're going to change that percent to a decimal, so that's 0.042. So we have 0.042 on the top, and this is getting compounded quarterly. Quarterly means n equals 4, so the 4 goes on the bottom, okay? And then whatever number goes on the bottom also goes here, and then our t is time. We don't know the time is, so we're going to leave it as t. All right, so that's our Abby function. This is our Brett function, so B of t, compounding continuously, PERT, right? So they both start with 8,000. His is compounded continuously, which means that we're going to use our E. The R, Brett's interest rate is 0.039, so we're going to put 0.039 times T. So that is our Abby function and our Brett function. Abby function and our Brett function, okay? Says determine who will have more money in their account when the twins turn 18 years old. So we want to find A of 18 and we want to find B of 18. All right, we could do that. So you're going to plug this into the calculator. So we have our calculator here. Let's clear it. So we're going to have 8,000 parentheses 1 plus. We have a fraction alpha y equals option number 1. So we're going to put 0.042 over 4. Close those parentheses. Oh, take that out. Go to the right. Now close the parentheses. Raise it to the 4 times, and our t is 18 in this case. And we're going to hit enter. So now we have A of 18 is equal to $16,970, and it says to the nearest cent, right? So this is 9,900, okay? Or 90 cents. All right. Then we're going to do the same thing with Brett. And when we do that, you're going to get 16,142.274. Okay, so how do we do this one? 8,000, right? E is above the ln to the 0.039, and then we're going to put times 18. Remember that 18 has to stay on the top, and that's how we get our answer. Okay, and then it says how much more money, right? So it says, and find the difference in amounts. So how much more? So we're going to subtract the two of these, and that's going to be 828.626. But it says to the nearest cent, so this is going to be about 828.63 cents. That's the difference in the amounts. Okay. All right. So that right there is guaranteeing us 4 points. For the next one, it says algebraically determine to the nearest tenth of the year how long it takes for Brett's account to triple in value. Okay. So Brett's account is A equals, that's our A PERT. Okay. So our amount that we're starting with is 8,000, 8e to the 0.039t. So we want to know how long does it take for this to triple. What is 8,000 tripled times 3 is 24,000. Okay, so we want to know 24,000. If you did not know how to do this algebraically, again, y1, y2, see where they meet. But we can do this algebraically. So how do you get rid of we want to get the t right here by itself, okay? I was trying to change colors. We're trying to get the t here by itself. So we want to get rid of this 8,000 first. This is being held together by multiplication. Opposite of multiplication is division. So we're going to divide both sides by 8,000. So we get 3 is equal to e to the 0.039t. Okay. So now how do we get rid of an e? We know this, right? Look at our calculator. The e is above the ln button. So how do we get rid of an e? We ln both sides. Let me go to black. So we're going to do ln of 3 and ln of e. As soon as the ln and the e are next to each other, they're going to cancel out. So I have 0.039t is equal to ln of 3. This is being held together by multiplication. Divide by 0.039, divide by 0.039, and this becomes a straight calculator question, right? So go to my calculator, alpha y equals option number 1. So I'm going to do ln, which is above the store, of 3. Let's close that baby. And then divided by 0.039, hit enter, and I get about 28 to the nearest tenth is 28.2. So t is about 28. Why did I write the 8 first? 28.2. And this is how long it takes for this is years. All right. So out of 6 points right now, we have all 6 if you were able to do that. And that is our Regents. Done. Good job. Thank you.